All right. Hello, everyone. Hope you're all doing well. Welcome to our Rust workshop. Before we get started, we have a few announcements to go over. And if you haven't signed in already, make sure that you snap that QR code that's in the top left or go down to one of the links below. All right, so if any of you are not familiar with Slido, it's what we use as our open forum during our meetings so that you can ask questions and they can be asked at an appropriate time so that we can get to everybody's question, especially since we're on a virtual platform. So go over to sli.do and then enter the room code RUST. And there you'll be able to ask any questions and we'll make sure that we get those answered for you. And paying member dues, if you haven't paid member dues yet and you'd like to become a member, you can pay online at acm-utsa.org/join, or simply snap that QR code right there. I think most of us are probably already on Slack, but if you're not and you want to be able to keep in touch with any of our announcements or anything like that, you can either pay dues online and that will automatically send you an invitation. Or if you'd like to just browse, if you're not sure if you're going to be a member or anything, go ahead and send an email to council@acmutsa.org. And in Slack, in case you're unfamiliar with some of our channels, these are some of the non-default channels that we have: hackathons, careers, and opportunities, all pretty self-explanatory. We try to post in these anytime that we get any information from anywhere so that you guys can stay up to date on all stuff going on in and out of ACM UTSA. And our social media, we obviously have a YouTube, you're on it. And then Instagram, Twitter, Facebook, and LinkedIn if you want to connect with us professionally. All of these links are here, and then you can also check them out in the links below in the description. We have our ACM Discord, which is pretty exciting. This is kind of a nice social space that we can kind of get together and do some fun activities, especially since we're all kind of at home at this point. It's nice to kind of just take a break and work with some of the other members on, working on some movies or playing games or anything like that. So if you're interested in socializing, I would definitely recommend being a part of our Discord channel. All right, some upcoming events. Really just ICPC, that's on Saturday, and that's in the ICPC Discord. So if you're interested in data structures or algorithms or just getting some practice, maybe for coding interviews and things like that, I would definitely recommend checking out ICPC. And so that's pretty much it. So without further ado, I'm going to go ahead and hand it over to Russell Gardner. He's going to be doing our Rust workshop. So Russell, why don't you take it away?
Sure thing. Thank you. All right, guys. It's my first time trying to do this kind of streaming live, so we'll see how it goes. So let's see over here. Share my glorious screen. Okay. Okay, we're going to be talking about Rust today. Now, Rust is I have a little tagline here, prepare yourself for ludicrous speed, because a lot of Rust advertising is that it's very fast. In reality, a lot of the computation says it's as fast as C++, which is already pretty fast, but it's used a lot in any kind of systems programming applications. So a lot of that stuff, a lot of people have been using it as kind of a popular thing for kind of game development, making game engines in particular, which is pretty interesting application for it as well as everything else. But anything that's really kind of a systems programming application, it fits right in there. That's what they're trying to target pretty much. There is a little bit of web dev they're kind of working on, but the system application is what's the most built up right now. So we're going to go a little bit over, why learn Rust, kind of what is Rust, and then we're going to take a look at some code samples of it. I got some, a couple things prepared to kind of get an idea of what Rust is and this and that, but I'm going to talk a little bit about it first. Not too terribly long, but we will we'll see how long it takes and what comes of it. And I'll stop a few here and there to ask questions, or you guys can always ask questions in the chat, and Matt will interrupt me if we got one, and I'll answer the best of my ability. So let's get into it. So on a real simple level, the main things of Rust that they like to promote is concurrency, memory safety, which is very similar to what we did with Kotlin. That was a big deal with Kotlin. Zero cost abstraction, which I don't know too much about, but what I can tell you is it's basically along the lines of whether you do something automatically or manually, it won't add any additional overhead cost to doing something manually or automatically. It should be the same. So ideally that helps with the speed. That's the main thing. And then the cargo packet manager, they call their packet manager cargo and crates. And it's a pretty easy to use system. And it's nice because you'll see a little bit of me when I'm trying to run some code. It's mainly run on Linux and Mac, but it could easily run in Windows because I'm running in Windows. It's just some of the command lines change, but none of the code itself changes. It's really just the like the command lines and certain things like that. But the nice thing about the cargo is that it kind of universalizes everything. So if you're running your Rust programs with cargo, you don't have to worry about learning like two different systems. And it's not too bad, but I'll talk a little bit about it. So the idea of concurrency, it's kind of you hear parallel programming a lot, but you don't necessarily hear a lot about concurrent programming. Well, I mean, maybe you do, but not on my class level. But it's the idea of saying it's the opposite of parallel programming, where parallel programming is talking about, different parts of the program executing at the same time, like I have written there. We're talking instead about different parts of the program executing independently of each other. So Rust really likes dealing with the concurrent programming, and the way they I was reading some of the things that the developers were saying, and they've said while they were trying to figure out a lot of the memory security issues, they kind of figured out that the concurrent programming worked really good with it, and so they pushed really hard into it. And what's kind of interesting about Rust is that a lot of the concurrency errors, they actually make them compile time errors rather than runtime. So it's really nice in the notion that normally when you have an error like that, where it's a runtime error, you have to run through your code and debug it and debug it and debug it. And if you're running through something that's just a bunch of data, that could take forever to find the problem. Well, Rust actually does not let concurrency errors even finish compiling. It'll stop it ahead of time, and it actually will display an error. You may still have to do some figuring out why it's going on, but at least it'll point you in the right direction versus something like C, where you could have an error in your runtime and it might take forever to find it. So it's kind of nice that way. It kind of helps you with that, which is more pleasant. So a little bit about what is Rust. It's created by Mozilla, which is the people who make Firefox. It's a pretty high performance system programming language, but though they're expanding the applications of it. And syntactically, it's pretty similar to C and C++. A lot of people compare it. In fact, when you install it on Windows, they recommend you install Visual Studio Code with the C++ build add-ons, extensions, so that it automatically applies everything it needs from C++ in it. So the idea is, I don't have the slides in here, I should have put them in, but if you're installing on a Linux or a Mac, you can just go straight to the command line and put it in on their website. They have it right there. On Windows, you can install, like I said, they recommend C++ because it'll install automatically. But you install C++ via VS Code, and then they have a Rust up tool, which is on their website. Super easy to use. You just boop it in, turn it on. If it's not going to work, they'll tell you what you need exactly. You load it, it'll load automatically, and then you just add the Rust RLS extension, which I believe is Rust Language Server, into VS Code, and then you will be good to go. I kind of use a combo of VS Code to actually do the coding, and I use Windows PowerShell to actually do the executions, kind of on a command line, similar to C. Now, the nice other thing about Rust is that it's, like I said, kind of similar to what we did with Kotlin before, where the language is designed to ensure memory safety. But what's interesting is it does so without garbage collection. So it's in this really interesting hybrid kind of thing where it's, it doesn't require you to allocate or free memory like a C or C++, but it doesn't have the overhead the garbage collection does either. So I'll talk a little bit about ownership. That's what they call it, the concept of ownership. But what's also interesting is that it does not allow you to, by default at least, use null pointers and dangling references in what is perceived to be safe code. So it's kind of nice that way. It's almost like once you kind of get used to, because there's a few things you have to kind of get around, and I was trying to do it. I don't think I have too many good examples of it, but it's kind of a broad concept and it's a little different, but and kind of the application of what they're talking about, it seems to be pretty nice. It's a little bit nicer coding, especially without having to like allocate stuff. Like in C, that would be like the biggest difficulty. Oh, allocating your memory, making sure you free it, and a lot of stuff with pointers. It kind of writes in a way that kind of helps you deal with that. So, ownership. It's kind of sort of like a hybrid in a way between kind of the memory management you have to do with C or C++ and garbage collection, like in Java. So it's kind of based on the fact that all values have a unique owner, and that the scope is within the scope of the owner. So the values can be passed to each other, and they can be passed here and there, but it's the idea of only one thing has ownership over it. So you can do things like you can still pass, and it's a really big deal for the immutable types are just by value for Rust. So all values are by default immutable, meaning that you can't reassign them with the same thing. You would have to reassign a new variable with the same name, which I'll show you a few examples of. But you can also declare something as mutable. And they do that so by default, you're writing in a safer code manner. So you, by default, if you don't tell it to be mutable, it's going to be immutable, which is safer and won't cause errors. So you're still allowed to cause errors in a manner of speaking, but the idea is saying once you learn enough about the language and what you want to code, you'll know when you want a mutable variable versus not. And so it kind of helps to prevent you from making mistakes. Kind of really built into the language. That's how they wrote it. The compiler is a Rust C compiler. It basically enforces these rules at compile time. So a lot of the way they wrote this language is a lot of the error checking and the error handling happens at compile time rather than runtime. So sometimes it can take a little while to compile, but what's nice about it is that it has a lot more opportunities to give you your error back before you have to like throw it into runtime and this and that. And the nice thing also about having a C-like compiler versus like Java or Python is you can actually write a piece of code and you can just give it to someone. You can just give them the executable and they could run it. They don't need to download Rust to actually run this. So that's kind of an advantage in manner of speaking over, it's not just Rust, but anything with like more like a C-like operating where you have to compile and then run. It's kind of a byproduct. So that's kind of like a lot of the basics out of the way. So we can get talking into a little bit of the actual coding now. So we can start for a very basic hello world. I'll probably do it again once we get into the actual like little coding examples. But the idea is saying is that it's pretty simple. It should look like a lot of other languages with little syntactical differences. So any function is going to be headed by an fn. But then, like most languages, you get an fn main with the brackets. That's where your parameters would go. And then it's encapsulated by curly brackets. We're using a print line statement here just to print hello world. What is kind of interesting here, though, is that the exclamation point is actually a Rust macro. And so kind of the difference in Rust between a function and a macro is that a function should always have like one input and one output. But a macro in regards to Rust allows you to have multiple variables or multiple data types. And it kind of like interprets what it is. So in this case, we have the top picture, which is just the very basic, hello world. It's just a string and that's it. But the bottom one allows you to save a variable using let, which I'll show you a couple examples of that. So I save, world into name. I let it, so that's what you're allowed to do it. And then I called it into the print line statement. So in one case, you have this Rust macro where it's only taking just a string. And you have another case where you have this Rust macro taking a string and a variable that is also a string, but the idea is saying, oh, it's a literal string and then a variable. So it's kind of in itself, it can mix and match, within what it's programmed to do. And you can write your own custom ones and they have their own baked in ones like their simple print line statement. So when it comes to running, it's just like C and C++. And the idea is saying you got to compile your code and you got to run it. So for more simple programs, and this is like without taking advantage of the cargo. So if you're just writing very basic, simple programs, you don't really have a need to use cargo. It's handy, but it's not necessary, especially if you just want to like bang something out real quick. So without using cargo, you would run basically Rust C, the name of your thing .rs. So all files of Rust will always end in .rs. That's the extension for it. So you would compile Rust C, the name I put example here, .rs. In the picture you can see main.rs. And then in Linux, you run it with a /example or just the name. In Windows, you have to use a \exe because when you compile it in Windows, it'll actually give you a executable. Where in Linux and Mac, it still gives you an executable, it's just not under the designation of exe. So little discrepancy there. That's kind of what I was talking about with cargo. Will make that universal, where with on the command line with Windows PowerShell versus Linux and Mac, there's a little discrepancy. It isn't too bad, but it's something to be aware of. So in this case, you can see the Rust C main.rs. And the next line, I actually run it. So that's how you would just run it. You just call it straight up and prints out good old hello world. And there we go.
Hey, Russell, we have a quick question.
Yeah, sure. Perfect.
So the question is, what string type should you use with Rust?
In regards to what string type?
I'm going to give the person who asked that a chance to maybe clarify what they mean by that. Russell, go ahead. If they respond, I'll let you know.
Yeah, sure thing. So we might have a little delay to get answers, but we'll try to answer questions and come back and forth, and we can do that. So I'm going to talk a little bit about cargo in the meantime. So cargo is Rust's, it's a build system and a package manager. So compiling of Rust, like I said before, is perfectly fine for simple programs. But anything that starts to grow in size or you kind of want to share, cargo is really handy for. It's actually built into Rust. You could always check which version you have. Cargo _version, a lot of other languages like this on your command line. If it pops up with a version number, cool, you got it. And for all intents and purposes, it should be installed. It's really more of maybe you'll have a Windows problem. I didn't have it though. It was pretty simple. So it's pretty awesome to just be able to jump into a language most other languages nowadays. But so it's really handy for handling building code, downloading libraries, managing your dependencies that your code actually relies on. It kind of sets up the beginnings of Git for you. So you can kind of have a system version control, which is actually really cool. It just automatically handles that. It sets you up really nice. Rust calls their packages crates. So the actual, I don't know if I want to call it engine, but the actual force, the thing that's driving it is called cargo. For your individual packages, Rust calls crates. So I will show you an example of this too once we get going in the actual live demonstration, so to speak, of this. I'm just going to bring up some stuff, show you this, how it works. Because all of this is the basic to using it, but it's honestly all very simple. So cargos are super simple to use. It was actually, it seems such a complicated thing to get a hold of, but super simple. So the command line is literally as simple as just cargo new and then whatever you want to name your whole project. So it'll take the given name and it'll actually create a source, a whole directory for you. It'll make a source directory. It'll actually get you I don't know if it makes you an actual GitHub repo if you have GitHub, for example, GitHub integration, but it does start with a gitignore file straight up in there. You get a cargo toml. I'm not sure how they want to say, or toml. It is a file that cargo automatically makes, and it helps to manage the information in regards to your package. So the little screenshot up top shows the command line, what you're going to see after it's made. So I make it, I go into it, and I ls it to show it's there, and then I actually opened up the toml file, and it stands for Tom's Obvious Minimal Language, which I thought was kind of humorous. But it's their configuration format. So you can see everything is listed in what it comes under. So everything under package will be under package until it reaches another heading like dependencies. So you can actually manually enter things in this package, or you can take them out, or you can change them by itself. Dependencies are where your libraries are going to go. So whatever libraries you add, or you can add in your files, or you can add them to dependencies manually. it will actually update and vice versa and keep it going for you and keep it organized. So it's really nice because it kind of sets you up with a automatic, whatchamacallit, kind of a GitHub setup, an automatic, like, great place to start scaling up and down. So they're pretty handy and they're really easy to run. So when it comes to like time to compile your projects, because remember in this language, you have to compile and then you're allowed to run it. With Cargo, you just have to be in the directory, like the head directory of what project you're working on. And if you just put Cargo build, it'll automatically just run it, or compile it, I should say. It'll automatically compile it, which is, pretty cool, pretty handy. You just have to be there and it'll work. To run it, it requires you to actually put in this string, target debug, and then the name of it. And then it's the / is the name of it.exe for Windows. You can also run Cargo run, and it'll automatically build and run your code in one command, which is pretty handy if you're just like, oh, let me, I just changed one thing, I'm ready to go. Boom. I believe there's another command called Cargo check. And so what build does, it'll actually compile and it'll remake the exe or the executable. Where when you use Cargo check, what it does instead is it doesn't rebuild your executable, but it does recompile it. And so where it would take time to do the build, especially if you're like want to change one thing and compile again, and want to change one thing and compile again, you can actually save yourself a little bit of time and effort by just putting Cargo check instead. And it works in the same way. You just got to be in your like the head of your directory for this file. But I thought that was pretty cool. So it automatically builds it, makes your executable, all this other stuff. But you can also just run it to purely just check for words. But yeah, so to build it, and yeah, it's pretty cool. So I'm going to go over some basic storing valuable stuff. I have like a few code snippets, and I'll mess around with the shell and everything else to show you how to get working on it. But so I mentioned before in Rust, variables are mutable by default, and you declare them by saying let. And it's kind of like a few of the languages in this case. You don't have to explicitly tell it what type the variable is. You can. It's totally allowed in one of the examples I showed you, because they had a little demo thing of kind of making a guessing game, which I'll show you. And there's an example in there explicitly telling it this is going to be a string. So cool. In this case, I want the picture on the right is just a simple example of how to declare a mutable versus a mutable variable. And that should work for every data type. The data types in Rust are, at least your primitive data types, you got integers, characters, floats, and strings, if I remember right. Got it right here. I can double check that real quick while I'm talking. But you do have access to decimal, hex, octal, binary. Like I said, it's very low level. It can reach low level like C does, so you can actually get all the way down to like bit level stuff, which is pretty cool. But yeah, integers, floats, basic numeric operations, and Boolean. That's right, it has a Boolean type, unlike C does, and character type. You do have access to strings though, which is nice. So it has a lot of the kind of like the similarities of C, but also with like some bonuses involved in it. And as far as flow control, it's very similar once again to C and C++, but it has some nuances. If I remember right, no, I don't remember the thing about the ifs. There was a thing about the ifs that I don't remember. I should have written it down. I'll have to get back to anybody who has a question on that. But feel free to ask me in the Slack. You can at me, and I will get back to you on that, because I don't remember off the top of my head. But that's totally kosher. But it's very similar. But the idea is saying it's like C or C++, but it has a lot of deeper ability to control your flow control, which is nice. It's pleasant to use. You actually have some compound types. You have tuple types, so you can like list almost like a list of integers or different types even, and you can kind of combine them together to give you that. You also have, of course, arrays. You have lists, you have array elements, all other fun stuff. Most of the standard stuff you come to expect. So the code on the left is an example of a code that would actually not work. It won't compile. And it's kind of like a little nuance you kind of learn with C. And that's because the variable of X, when it's first declared, is actually an immutable type. Now, if you don't remember what an immutable type is, it basically means that once you assign the value, it cannot be rewritten, like reassigned, or like overridden. You have to completely reassign it to a new variable. So in this case, the function on the left will not work explicitly because it's assigned as a immutable type. Now, let me see, where's my little note here? And I can actually, was going to show you, I believe. Well, I could probably back out. Let's see how much I got left. Okay, I think this is the end, so I can show you the end, and then we can start getting into a little bit of the coding, which should be pretty fun and examples. So I have kind of one last question as a kind of query in the sense of this will be a good example of kind of mutable versus immutable to see if you kind of get it or not. So the question is simply which one of these would compile, and it's essentially you're declaring a string of spaces in each one, but one of them compiles and one of them doesn't compile. So if anybody wants to answer and say which one compiles, just top or bottom, and if you have a clue as to why or why not, have a guess at it. It's kind of like a little tricky thing. I thought was kind of clever. Remember that with just the let, it's saying it's immutable, which is the default, and then the let mut is turning it into a mutable, declaring it as a mutable variable, which means you can change its value just by referencing it. You don't have to like redeclare it.
So there's a couple comments in the YouTube. One person says second compiles. Two people say the top one. Some people say both. Some people say neither. What's the answer, Russell?
Okay, so the answer is actually the top one, believe it or not. So this is a little tricky thing where the function of spaces.lang actually returns an integer. So the bottom one doesn't compile because it's a mutable. So it actually, because it was given a string type, it actually expects a string type. But in the process of calling string.len, it actually ends up returning an integer. And with mutable types, it's allowed to be rewritten, but because of it's still expecting what it was given. So since it was given a string, it's expecting a string, and since it gets an integer, it's going to not compile. The top one allows that to happen because you're not just re-referencing the value and giving it a new one, you're completely redefining the variable. Granted, they're both immutables, and it shouldn't be allowed to be written over, but in this case, you're declaring a variable, which is a set of spaces, right? Like 3 or 4 spaces. And then the bottom one actually allows you to compile because you're redeclaring that variable. And since it has a similar name, it's going to take the new one as the precedent of saying, oh, you want this now. And so it'll actually save it. But instead of being a string of spaces, it's going to give you the actual value from the string of spaces. So it's kind of interesting how it lets you reference the old one while still declaring a new variable of spaces of a completely different type. So it's kind of an interesting example of the interaction between immutable, mutable types in regards to like, there's more languages that have it than just Rust, but I thought it was like an interesting example they had in the documentation that kind of showed it off. So yeah, this will be a good quick break. If anybody has any questions in regards to like anything I've gone over so far, I'm going to mostly go over some code examples now of different things in Rust, kind of, using the command line to start a few things within that. But, if anybody's got any questions, feel free to stop me in the middle of it. Okay. Well, I'm going to carry on in the meantime.
We actually do have a question.
Oh, sweet. Cool.
So how has cargo felt versus other dependency tools?
How does cargo fail versus other dependency rules?
How has it felt versus other dependency tools?
Oh, how has it felt? I haven't used too many others, but I do find it to be absolutely harmless to learn how to use. So, so far, it's been actually pleasant to work with. It's super easy to learn, and this and that. There's a small example of me trying to work with it with kind of like a demo, kind of like guessing game they made. But it seems pretty interesting how you can tell it to pull a specific library. The standard one's already included in it. So in this case, I pulled the random library to generate a random number, because the guessing game is the idea of saying, oh, it's going to pull a random number and you have to guess what it is, and I'll tell you if it's high, low, or equal. But if you wanted to pull a specific version of the library, it actually allows you to just straight up declare, hey, I want this specific version and not that version. And what's kind of nice about it, though, is if you don't have it already downloaded, it'll download it plus everything up to the modern one. So it's kind of interesting in the sense of you can download an older version, but you can receive all the new ones at the same time. So if you ever want to use a new one, you can just grab it. But so far, from my experience of not having too much familiar with a lot of package managing software, it was very harmless. So for someone who had not much experience, to be able to be, fairly competent enough to mess around with and play with it, it's pretty straightforward. So pretty nice in that department.
Great.
Hope that
we have another question.
Gives you some feeling. Yeah, next one.
So if you take off the let in the second line of the first example, will it still compile?
The second line of the first example, it will not in this case because it is a immutable type. And with the immutable types, you're not allowed to reassign a new data to them, even if it was a string. So that's kind of the caveat. It's kind of part of the way they do memory control, or memory safety, I should say, is that because they're all immutable types by default, you kind of have to work with it or around it. And then it's kind of like the exception to the rule should be mutable types. So in this case, the kind of rule with mutable types is it works like a constant. In fact, it's kind of weird. You can still call constants in Rust, but they still will tell you to just use an immutable type instead. So I wonder why they even added it. Maybe there's kind of an edge case I'm not familiar with yet that you would rather use a constant for. But it works with a constant if you're familiar with it. So the idea is saying it cannot be reassigned. It has to be its value. But with the caveat here, if you can actually redefine the variable, and that's kind of what you're doing in the top one, is you're redefining spaces, and it's actually overriding the previous declaration of the variable of spaces, and then you're reassigning it. But what's kind of interesting in this case is that Rust will still allow you to pull the information off of the previous spaces. It grabs that information and then assigns it to this new variable of spaces. Oh, and I didn't talk about it before, but it's kind of interesting. So they, the way it does kind of a memory management, I'm going to go back a little bit here because I want to mention this. It's kind of dealing with ownership, but it's its own system. It's kind of like I said before, it's a hybrid between C and Java. So it automatically handles allocation and freeing. In that sense, it's still doing C memory management. But it doesn't quite run like Java, where Java will halt every so often, run through all your memory, find out what's not being used anymore, and free it consecutively, but that takes time. Rust kind of works in a way where it runs like C, where it just runs on its own and it follows instructions. But if it runs into an issue where it's saying, oh, I might run out of memory, it will actually search through like kind of almost the middle ahead of time to find, but only by like blocks, not the entire memory the code is taking up. So it is in a way like a very small and nuanced and specific version of the garbage collection, but it's not as like time consuming. It only activates after like a certain amount of cycles if it's a really long running program, but only in like specific areas too of like high traffic, or it activates when it's sensing that a block is full. So it's kind of interesting how it's still using the automated nature of garbage collection, but it's very focused and very discrete. And that's what allows it to actually be kind of fast. So I wanted to mention that real quick before we get into actually doing some code examples and stuff. So I'm going to start with a basic hello world. We're going to do one right here. So if you came over, that's my video call. So I have my command line here, Windows PowerShell. And, it's going to run all the same commands like this and that. You can cd into whatever you want. But I'm going to make a new file here. And we're going to save it. I'll select me a Rust. We'll just say Google. So obviously that's all standard stuff. You can just save it like that. So show you or to prove to you that this all works, you got a main, we got a nice function here. And we're going to give ourselves a hello world. So a lot of this is really very similar. It's encapsulated with curly brackets. You got a semicolon to end your lines with. And if you had any parameters, they'd go up here in main. So I am going to do this. So it's in rest hello world. Okay, cool. And come back to my command line here. Yep, and there it is in new world. So I'm going to run C and my new world.
Hey, Russell, can you make that font a little bit larger?
Yeah, on the command line or the PowerShell? Or the
in VS Code, actually.
VS Code, okay. Do you know how to do that?
Standard seems to be Control plus.
Control plus? Ah. Is that good?
I think that should be good. Thanks, Russell.
Okay, yeah, no problem. All right, so I came over here. I ran, because like I said, I didn't use cargo in this. This is just a very simple, basic, let's get hello world working. So I used ruste. I called new world. We actually end up looking at the files over here. I started with an RS file, which is here. But then once I declared it, at least in Windows, it's going to make a debugging file, and it's going to make your exe right here, which is new world. In a Linux or Mac system, it's just going to have your Rust file and your application file. So I'm going to come over here. I should just be able to declare new world.exe, and boom, huzzah. Simple as that. So this is the example of a kind of what I was showing before, the idea of saying that the print line function, as we're used to calling, is actually a Rust macro. And so in this example, which we just did, very basic, just simple hello world. That's it. In this case, we're actually declaring something else. So we're actually sitting here and declaring world. If we want, we can actually pull out that example from before. Let me pull it up here. This will be a decent place to show it because in this case, it's just spaces of letters, right? So I should be able to come over here and see I had spaces. So let's just declare it as a mut or a mute, I should say. And then say name equals, what we have here, spaces outline. So name dot line. All right, this should be good. Oh, did I get it right? Yep, okay, cool. Save. Come back here, and we are going to ruste our main.rs. Now, see, it's going to complain here. Unexpected, basically, it expected a string, and it found a unsigned integer. So you can, it still has all the things where you can assign signed and unsigned integers of actually various values, which is kind of interesting. You can tell it how many bits you want to use from as low as like 8 all the way up to, I think it's 128, which is pretty interesting for like kind of like a memory management control. You can specifically say, oh, I only want an integer of this size, and that's all it's going to be. But in this case, it expected a string, and it received a unsigned int because of what len kicks back. So in this case, we can go back, just to show that. We can say right over here again. This should still be good. So we're going to recompile.
Sorry, Russell, one more time. If you have an opportunity to make the font larger for PowerShell as well, that would be great.
Sure. Do you know how to go about that?
Not a PowerShell user, sorry.
Just try doing the Control plus.
Control plus again? Gotcha. I don't think that's going to do it.
No luck.
Anyone want to Google it real quick?
It's probably in the right-click menu. If you right-click on the top bar.
Definitely bigger. Is that better or larger?
It looks good to me. I'll let you know. Thanks.
Okay, cool. All right, so we recompiled main, or I believe it was main. Let me double check here real quick. We're going. Yep, main.rs. That's our Rust file. So we came over here, and now we're going to run. Not that. Boom. Main.exe. And then, huzzah! It printed our value, hello 5 instead of hello world in this case. But there you go. So that's at least a live demonstration of what one works, what it doesn't. Here's a little example of what some error code looks out. It uses a lot of color. It's pretty nice. It's definitely nicer than C in some cases. It'll specifically say, this is your problem. We expected this and of this size, and so on and so forth. So I should show an example of cargo next. So we did some basic coding here. I showed some basic immutable versus immutable working on going on here. So we're going to back out here. I have I believe it's a projects, yep. And I believe I have, yep, the guessing game here. I deleted my hello cargo. So I am actually going to make I believe it's cargo new, and we're going to name it hello. That's not hello. Hello cargo. And boom, we created a hello cargo. You can see right here, I had my guessing game thing from before. I've just made a hello cargo. So this is a me showing off kind of what cargo does. So we're going to go into that now. Okay, so it does a number of things here. So it makes their source file. So you can see here, like I said, it kind of has a kind of a, not GitHub, but just Git integration. So for version control, it automatically sets you up with that, which is pretty handy. And this is your TOML file. I'll actually open that up in a second. I'm just going to go into my source. And it automatically sets you up with a main.rs. And then, in fact, it actually is automatically hello world. So that's kind of interesting. So we're going to come over here. We're done with that. And we are done with that example. And we're going to open a folder. Cool. So here is kind of what a TOML file looks like. You kind of saw it before. I'll show you the one from the guessing game I made. But the idea is saying, okay, well, here's your kind of your information in regards to what all this is. And if you had any dependencies, any libraries that you want to add kind of to your whole the whole project, not just a single file, you could add them here, and they would be like ready to access and this and that. So of course you have a get ignore, doesn't have anything in it right now because it's not set up. And then you have your main.rs functioning. So here's this. You can see this is all it sets up for you, which is kind of nice. Kind of sets you up in a way to grow, expand, or just share whatever you're working on. And to kind of promote that aspect, so I'm going to pull out of the source file real quick. And it should compile, or at least we should be able to build by calling a cargo build. Now it'll say building, as you can see, and it's finished on optimizing debugging info. You could tell it to optimize. It'll take more time. In this case, there's no need. Let's see, cargo, and it should be a run. Yep, or actually I ran run, which will build and run at the same time. So if I want to do the other one, I believe it's target back debug back. I believe it's main.exe. Oh, I wrote that wrong. Well, Target debug. I'm actually not sure why it's not working. Oh, I the name of the thing, I believe. Okay, maybe that's it. What did I call it? Hello, card. Aha, that's what it was. You got to put the name of the actual a crate, not the name of the file inside of it, because it'll run the whole thing. So boom, run crate. You could also do a cargo check. And remember that cargo check is handy because it doesn't actually have to rebuild the executable. So when you get a really large file you're working on, that'll save you a lot of time, not having to rebuild it every time if you just want to check a computation, a compiling error, or just check what the work you did is. So we got some minutes left. I'm going to show you all it's kind of like a demo they had of kind of making a program, like I said, this kind of game they have here. I should open this as a file or folder. Some game. This is set up with cargo. So boom. Come on. All right, so this is an example of your dependency right here. I just used this random one, but you just set it up right here. This is explicitly saying a version. And if I said something like, oh, 0.6.2, it'll use that one instead because, like I mentioned before, it'll pull every version of this library from the one you declare forward. So if you ever say, oh, I need to update it for whatever reason or downgrade it for whatever reason, you can always go back to the one you installed originally, and you can always go lower. You just have to re-download it. But it will allow you to just up it. I'm pretty sure if it went to 6, it would probably not cause an issue. But like I said, we can take a look at this kind of coding example right here. Let's see, is there? Okay, just put it one back. Is that still a good size?
I think that should be fine.
Okay, cool. Just we can see more of the code. So it's going to look a lot like a lot of other codes here. You start up here and you have your library declarations. So this is pulling from standards. You declare it as use. It'll be whatever library you're pulling from, double colons, and what it is. So this is a I/O. So it's going to allow us to actually attain user input. This is ordering. So it kind of allows you to do a kind of like a switch case type deal, but in its own thing. I'll show and explain it. And this is where we pulled in random, and we pulled it in with a range. So the whole idea of this kind of game, like I said before, is it'll pull a random number. In this case, it'll straight up tell you because it's just, to show off Rust a little bit and, basic coding stuff. But the idea is, okay, well, the user will guess the number and it'll tell them if it's high, low, or spot on. And if it's not spot on, it's going to make you go again and it'll tell you to keep on prompting you to it. So, pretty simple. You've seen this before. Rust macro print line, print what it is, just a single variable this time. And then you're going to declare a variable here. Now we're using let, which makes it a mutable type because that's our default. And this is where we're kind of calling our random. We're saying, oh, the secret number is going to be a random number from the range of 1 to 101. So that's how, example where your thing's being pulled in. But how you access your libraries for your functions, you have to declare where it's coming from. So in this case, you're saying, oh, I'm pulling from random, and then I'm pulling these functions out of random. So I come down here, got another macro in this case. We're doing one of those, it's 2 now. It's a string literal and a string variable. Or sorry, integer. And I don't know if I pointed out, but these double brackets inside your print lines, that's how you get your formatting in. So a simple loop is literally just declared as a loop. In this case, you just break out of it at the end. Nothing fancy with this loop. But you're allowed to just make this really simple loop. Just say loop and break, and you don't have to give it any test cases or what it's going to break out in itself because this is its kind of self-contained thing. But we're just prompting the user here. This is how you kind of set up your string here. This is a mutable one, so it's going to be able to be rewritten as long as it is also a string. In this case, you're just saying, oh, it's a new string. You're kind of saying it's empty. This is a case where normally, unless you explicitly did this, you're not really allowed to say it's null. You have to say it's new. In Rust will kind of interpret that as saying, oh, it's going to be filled at a later date. I expect that. And then okay, so here you've done that, and now you're saying, okay, now I'm going to use my IO library, and I'm going to pull from standard in because we're running this in command line. We're saying, hey, read the line, and we're going to throw that value into a guess. And if you can also kind of built in this kind of error exception here, just if it's not what you expected, or like something that doesn't work, it's just going to print out like failed to read the line, and it's kind of like error handling. Oh, so you're coming over here and you're actually checking your guess, and you're trying to say, okay, it needs to be an unsigned integer of 32 bits or bytes. Let me double check that. 32 bits. 32 bits. And you kind of pull another match here, like I said, which is kind of roughly like a switch case, but it's a Rust function where it says, okay, I'm going to match to all these things. And so I'm going to say, okay, well, I'm going to trim off anything else. I'm going to parse it down so it's just the number I want if it contains anything else. And I'm going to say, okay, if it's a number, this totally works. It's okay. If it's not a number, I'm going to basically reprompt and re-ask. Come down here. At this point, you've already kind of got past it. You said, okay, it's a guess. I'm going to print it out, which should be a, like I said, unsigned 32-bit integer. And then you can pull out another mass, and it's actually here going to compare. You can just call it .cmp on this integer, which is pretty handy. And you're going to compare it to the address of your secret number, the random number you originally got. And then you're seeing here, and this is where ordering comes in from the other standard library. It's part of comparison, the CMP, the comparing library. It only has it has its own library, but it only has these three functions: less, greater than, equal to. It's literally designed for this in a way. So if it's less than what you're comparing to, your secret number, it's going to give you too small, greater than too big, equals, it's going to print, you win, and break. And so this break right here is breaking actually out of the entire loop. But kind of the syntax here is you can kind of create these like additional I forget the term for them, but encapsulations ideally within interesting areas, and that's part of the not continuity. What's the word I'm looking for? Contingency? Concurrency. There we go. It's part of concurrency is what that's dealing with. Being able to isolate parts of it and run them independently in this and here, while the kind of greater program is still running. So running a little short on time, but has anybody got any questions in particular or anything else to like show or this and that?
Nothing's come through yet. I will let you know though.
Okay. This is a quick example of what they call shadowing, and this kind of dealt with the kind of the concept before of where we talked about mutable versus immutable versus mutable types. And this is just a quick, dirty example of how you allow this to happen. So this code will actually straight up work, and it will actually do the math going down. So you start off with 5, and you're saying, okay, let's take this value of x. I'm redeclaring it as the previous value of x plus 1, get yourself 6, and you're doing again, and then you're multiplying that value by 2, so you're getting 6 times 2 is 12. It's going to print out 12, which is just another example of kind of like shadowing right here. Thought I had my flow control example here. No, that's shadowing spaces, which we went over spaces before. Let me pull up flow control. Let me see if I can get some ifs and else's in here just to show you some examples of them. We're going to say, yeah, if x, because we know it is in this case, if x is, let's say, I can't remember if that allows me to do that here. If not equal to, let's say 13, because we know it's not going to be, just for example. No, if it is equal to 12, how about that? is it Boolean or is it normal? I think this is where I was coming before, where it might have been Boolean or not. No, it is equals equals. Cool. We're going to say if this is that, pop. Then we're going to say we're going to print the value. So this is going to work in this case just because it's a, we already know it's going to end up being 12. But if it ended up being anything else, it would essentially work. And we could just, it works very similar to things. You can just list a bunch of else ifs. You can list an ifs, ifs, else ifs, same deal. Should be similar to whatever else you've seen. You can kind of use let as an if in some cases, which is interesting. So we can say, so like this was very basic if. You could say, let me see, what's a way to set this up? Connection is true. Okay, so we can say, condition equal true. We could say let the number equal if condition. We could say 5 in this case, and that. And we can actually give it a else here, and we can just simply say 6. And you actually got to give it a semicolon there. So notes are pretty simple, same as you have seen. But we can say, okay, so it's basically going to say, okay, we're going to create this variable. We're going to let this number variable, which is going to be immutable here, exist if the condition is true. And then otherwise, if it's not true, it's going to be false. So that's kind of how you set up like a kind of like a basic flow control in this case. But you can actually do it with like variables. So kind of nice with the like immutable types and stuff.
Hey, Russell, before we get too far ahead, we have a couple of questions that are relevant here.
Yeah.
So the first one, with regard to shadowing, the original X, is it lost completely? And at the time, they were talking about the one that's on line 9 that's commented out right there.
Okay. In the case of putting this if statement in, or before I did all that?
Before all of that, so after you have the X and then you reassign it 2 times, are you able to ever retrieve the original X value?
Not that I'm aware of. It is in memory because where it assigns the new value of X is not, it doesn't overwrite it. It just resays, oh, this is your named value of X, wherever it decides to put in the future. So I imagine it's still in memory, but I am not sure if there's a way to reacquire it. There's kind of a lot of documentation, and they go. What's nice about it is they go really in depth over all the like the key concepts, and they have a lot of demos and this and that. But as far as saying, yeah, that.
And then the second question: do you know if Rust supports ternary operators?
Ternary.
For like conditions.
Yeah. Can certainly check. Let me pull up the document real quick. Kind of work with 2 computers here, so ternary. Let me just. That is a good question. Loops, ifs, whiles. I would think it would, seeing as it's, like I said, it is kind of based on C and C++. I know in C you have that ability, but I'm not seeing it explicitly said here. No problem with looking it up though real quick.
It doesn't seem like it, but there's also no point because you're also defining it with an if condition. already.
Yeah,
So
that's
it's
true.
similar to something like how you would do ternaries in Python.
Yeah. Yeah. Basically what Leon said. I'm seeing a couple things here and people are like, yeah, no, it doesn't support ternaries. So no, it does not support ternaries. Where's my flow control? Do we have any other questions, Matt?
We do have another question about concurrency. Would you like to answer that now or wait till the end?
Yeah, I'm kind of at the end. This is kind of like all I had actually like super prepared for today, but I plan on filling this out more and putting it up, kind of like to access, kind of have a lot more, and possibly throw this up on a repository to have a lot of the examples here. I will say the documentation helped me a lot. It's very good, but kind of like I said, kind of get a better understanding. I wanted to get a better understanding of the what do you call it? Ownership concept to really show it in code. I don't have that really prepared, which is one thing, and then a few other cases. But yeah, I can answer the concurrency.
Sure. They just want you to generally explain a little bit more how Rust uses concurrency.
Okay. Gotcha. It's a little out of my expertise, but I have the document. I did look it up before. I kind of know how it works under the hood. I didn't do too much work with it up front, but I do, like I said, I know it works with it where in other language, it kind of works with the concurrency where it lets it fall to the runtime. It'll actually do a lot of things up front to deal with it instead. Let's see, because they're talking about threads here. I actually didn't read that. That's interesting. Okay. I'll tell you what, those are the two big things that I was definitely wanting to hit is the concurrency and the ownership. Like I said, I'm basically, I could upload this now, but I'm also going to continue working on it a little bit to get it more fleshed out to actually have some good examples. Because I know here it deals with threads, obviously with the concurrency that kind of goes with the name of it, but I don't know enough right now. But I will say I will put it up and we shall make an announcement in the Slack channel about it, like when it's up, and have the stuff ready for it. And hopefully I can have a repository with examples of it too.
Great. Well, thank you, Russell. Really appreciate you putting together this workshop for us. It's a really, really interesting topic. So I'm glad that you're able to share this information with us.
Yeah, thank you for, well, everybody for stopping by at least. So.
All right, guys. If you have any questions for Russell, you can DM him on Slack. We'll be posting some follow-up materials like he mentioned just now. And if you're signing up for extra credit or anything like that with Dr. Robinson's class, make sure that you do sign in, and we'll just see you next time.